Okay, so in this video, we are going to go over naming conventions, or what we call in chemistry nomenclature. Now, it's important to understand that when we are going through each of these rules for naming compounds, some of the rules may not apply in certain situations, and in other situations, you may find that doing, let's say, rule number two, I'm doing that one first may be most beneficial. So you can have a read through this document. This is just the level 2 examples. But the general thing that I want you to take away from these rules overall is that the first idea that we are working with is that we need to what do you call it? We need to identify longest chain. It's the first step. Step number 2 in general is that we need to identify substituents. And functional groups. And then number 3 is ensuring that we assign numbers to the longest chain, to the longest chain, so that when you look at the substituents in general, so that when you look at the substituent or substituents, they have been assigned the lowest numbers, Okay, these in general are the rules that you need to understand, okay, in general. The second thing I want to go over with you is the idea of suffixes and prefixes, okay? So let's start off with suffix, okay? Suffix is when it is a portion. It's a portion of the name, and its suffix. So of course it will come after near the end, I should say. Portion of the. I'll read that twice. It's a portion of the name which tells us what functional group is present. So essentially, when you are looking at these compounds, if you see that we have the main functional group as an alkene, then you would see the suffix as -ane. If you see alkenes and alkynes, okay, they would be -ene, and this is -ine. If you see carboxylic acids, so if you see this functional group, the name should have a suffix, or at the end of the name it should have something that's close to oic acid. If you have an amine, Amines are a bit interesting. If they're gonna name it, if you're gonna use it as a suffix, then it's usually amine. And then alcohols as well as the other one. That's ol. Okay. So understanding this is really important because it allows us to complete the name. The other component is prefixes. And a prefix, okay, so pre obviously means before. A prefix tells us how many carbons are in the longest chain. Now it's important to recognize that it's only in the longest chain. We can have carbons branching off the longest chain. Okay, so we do need to make sure that it's not including all of the carbons some of the time. Okay, sometimes it is if it's just one straight chain, but if there's branches, it won't include those branches in the name. And so if we have the prefix of meth, usually that's signified by one carbon. Eth is two carbons. Prop is three carbons. Bute is four carbons. Pent, like pentagon, is five carbons. Hex, like hexagon, is six carbons. Hept is seven, like heptagon. Oct is eight. Non is nine carbons, and dec is 10 carbons. Okay, so you can have a read through these over here, but essentially we can go over a few examples. I should also say as well that if we have numbers, okay, in our name, they are related to the location, and usually it's like one, this is an example, as one, and then like a word. So this number shows what carbon, whatever it's talking about directly after is located at. So whatever is here, let's say an example is chloro. Then we would suggest that there is a chloro in the carbon number one position. Okay. And similarly, if we see two in another one, let's say it's ene, then we know that there is an alkene, which hopefully you remember to C double bond C. Okay, we know that there's an alkene on carbon number two. Carbon number two. Okay, that's how the numbers work. And then the last thing, or one of the last things, I keep saying last thing, but it's not really. The other thing that you need to remember is that numbers and words in a name, they can't be put next to each other. They need to be, they need to be separated by a dash. Separated by a dash. So anytime you're going to do like a number, okay, and then a word, you need to put a hyphen. Okay, this is separates a number from like a word. Okay. Excuse me. And numbers, when you have two numbers next to each other, two or more numbers next to each other, they are separated by a comma. You need a comma. Okay. You need a comma. Okay, so let's go over a few examples. Now I'm going to use a stick notation. It looks like something like this. Okay. Okay. And if you were wondering about stick notation, each of the corners here is counted as a carbon, and the ends as well count as a carbon. Okay. So if we try to name this, we can see that there is 1, 2, 3, 4, 5. These lines represent the bond. So this carbon is single bonded to another carbon, and we don't draw in the hydrogens because it'll take too long. So we have a 2, 3, 4, 5 carbon chain, okay, and in terms of the 5 carbon chain, it is just single bonds. So when we're looking at this, we can see that we can number it as 1, 2, 3, 4, 5. That's the longest chain. There's only one chain in this case, so that's fine. So that would make this pentane. Okay, let's look at another example. If you're wondering what that looks like, it would be like this. So we've got CH3, CH2, 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 1, 2, 3, 4, CH3. Okay, so that's what it looks like. Let's go to the second example. Let's try this one. Yeah. Okay, so when we label, we need to label the longest chain. Let's go 1, 2, 3, 4. Okay. Labeling 1 to 4 from left to right. Okay. Another way that we can label it is we can start from right and go towards the left. Okay. So we go 1, 2. This carbon over here is number 3, and we got 4. Okay. Now remember, when we were talking about the rules, we need to make sure that the substituent has the lowest assigned carbon. Okay, so hopefully you can see this group over here is branching off this main chain. Okay, and so we would signify this as a substituent. This is a substituent. Okay, and so how would we name this? Okay, um, let's just rub out this number 4. Let's do it separately, eh? Oh, okay, let's do it separately. So the first scenario is that way. The second scenario is labeling it from left to right. We got 1, 2, 3, 4. Okay, so hopefully you can see that the top one, this one over here, that's the correct one, because we can see that the substituent is on carbon number 2. In this case, carbon number 2, and the substituent over here is on carbon number 3 if we assigned it from um, right to left. Okay, and so we would pick the one with the lowest number. Okay, and so doing it this way is wrong. Doing it the second way over here, this is wrong. This is right. And so if we have a carbon group, this is a good point to say, if we have a carbon group as a substituent, okay, a carbon group, we usually try and count how many carbons are attached. So we have only one carbon, because remember this position here is a carbon, so it's C, and then we have 3 H's obviously bonded to it. Okay, so that's CH3, but overall it's only one carbon. Okay, and so we would denote that as meth. Okay, but because it's a branching, okay, chain, we say that it's YL. So any carbon chains, any carbon chains, any carbon chains that um any carbon chains that are branching any carbon chains that are branching is denoted with a prefix followed by a YL. Okay, and if they are a halogen, if they're a halogen, so this is for carbon chains. If it's a halogen that's a substituent, halogens, we just take it as like F means fluoro. Cl equals chloro. So we take those I's iodo. Br is bromo. Okay. Let's look at another example. Okay. Let's look at the example over here where we talk about yeah, and here. Okay. So let's label the longest chain. Hopefully you can see it goes 1, 2, 3, 4, 5. Okay. If we count any other one, let's say, let's pick a different color. Let's go green. Another case is that we can go 1, 2, 3, 4, but that's not the longest chain, right? So you just need to identify the longest chain. Okay, so that's our longest chain over here. And then we can see that the ones that are highlighted in yellow are substituents. So that's a substituent, that's a substituent. Now, let's go over the ways of counting it. So we can count it from left to right. 1, 2, 3, 4, 5. And the other way is from right to left. 1, 2, 3, 4, 5. But which one has the lowest assigned carbons for the substituent atoms? Well, in the top case, we have a 2 versus 2, 3. And then going from right to left, we have a 3 versus 4. So 2, 3 is obviously less than 3 and 4 overall. And so we would denote that this one is the proper way of labeling or counting the longest chain. And so the way that we do it would be that we would signify 2, 3. So remember that these are the locations of the substituents. Hyphen, because we're going to put a word. Now, instead of putting methyl, we're going to put dimethyl. And the reason why is because this di shows that we have 2 methyl groups. Okay, we have one here, one here. Okay, and this shows the location of the methyl group. Okay, and so we got 2, 3 dimethyl. The longest chain is 5, so then we will say pentane. Okay, so that's the correct name for this compound. Okay, let's look at carboxylic acids. Okay, so this is an example of a carboxylic acid. If you want to know what it actually looks like, we have 4 carbons with a double bond O and an OH over here. So remember, this carbon is related to that. This carbon is that carbon here. This one is that one. This one is this carbon here. And we don't draw in the hydrogens because it gets too messy. Okay. So Yeah, that's what it looks like. So usually when we are counting these functional groups, we can clearly see that this portion here is the major functional group. And so we would count this carbon as carbon number 1. And then there is really only one way of counting, right, to the left. So you go 1, 2, 3, 4. So we know that the suffix is the prefix is but. And then we have something called the suffix, which is oic, but we need to put anoic acid. Okay. Now this portion here is the prefix. This portion here is the suffix. What we have over here is called an infix. Okay. And this infix just suggests to everyone, okay, that in terms of the rest of the chain, it's only single bonds. Okay. So you don't need to worry too much about that, okay, because it rarely pops up in the exams. It's just something to note. Let's look at another example. Okay. Let's try and determine what's the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So we can see that the longest chain is here. 1, 2, 3, 4, 5, 6. 6. Yeah, I believe that's right. Okay. And then we can also see that we can label it from left to right. Okay. So in the second scenario, we have 1, 2, 3, 4, 5, 6. Okay. Now, as you can see in this situation, okay, we have the substituents on in the first case in carbon number 3 and carbon number 4. And over here, we also have the substituents in carbon number 3 and carbon number 4. Okay. So if we were to name the top one, okay, we would label it as 3, 3, 2, 3 methyl, because that's a methyl group. This is a methyl group. 4 ethyl. So F, because this is carbon number 1, carbon number 2 as a branching chain. Okay. So F, and then since it's a branching chain, we have to add YL. Okay. And then we say hexane because the longest chain is hexane, is 6 carbons. In the second scenario, we have 3 ethyl, 4 methyl hexane. So which one do you think is correct? Well, in both situations, we can see that the numbers don't change. We both have a 3 and a 4. But what's differing between these is that we have the methyl first in the top case, but we have the ethyl first in the second case. Okay, so understanding this, we need to remember that substituents, write this in red, substituents need to go in alphabetical order. Okay, And also alpha, so alphabetical order goes or takes priority over takes priority over number order, because sometimes you can see that the numbers will be different. Okay, like some will be ascending order, some will be descending order. Okay, but essentially this is the main thing you need to know over here, is that we need to go in alphabetical order. And so the top one would actually be wrong, because when we are comparing it, M and E, of course we know that E comes before M in the alphabet, so we need to put ethyl first. Okay. Um, yeah, it's important. Let's look at another example. Okay. Um, let's go here. Okay. So let's number this. 1, 2, 3, 4, 5. 5, 1, 2, 3, 5. Yep. And hopefully you can see as well that we shouldn't label the other way, because we'll get this. The substituents on 3 and 4 compared to the top case where we have it against 2 and 3. Okay, so the top case is the better option. So when we're doing this one, the largest chain is hex, 5, so that's pentane. Okay, and then we can see that we have a two methyl groups that is on number 2, and we have another methyl group that is on number 3. Okay, so we would go 2, 2, 3, trimethyl. I'm running out of space. Trimethyl. Trimethyl pentane. Okay. So that's the right name. Okay. And let's look at another one other easy example. Let's go to over here. Okay, and let's go. Yeah, so let's label again. 1, 2, 3, 4, 5. Okay, and this time we have a methyl group here, a methyl group here, and we actually have an ethyl group here. Okay, going this way. So we would label this one is as follows. We would go 2. We would go. Let's do it here. Let's know that this one would be 2-dimethyl. Okay. This portion here would be 3-ethyl. Okay. And we know that the longest chain is pentane. Yeah, pentane. Okay. So let's go pentane. Right. Which one would come first? The ethyl or the dimethyl? Now, when you're doing this one, some of you will say we put the D before E in the alphabet, but you would actually be wrong, because when we're considering alphabetical order, we are not considering this portion here. So we don't consider, let's do it in purple. we don't consider this portion here. We only look at the name. So let's do it in green. We only look at the M and the E. Okay, so when we're doing this one, it would be 3-ethyl 2-dimethyl. Okay, pentane. So I hope that helped you with understanding a few key components of organic chemistry naming. You can go through the rest of them, okay, and try your best to understand how to label these. But in terms of understanding how to name, it all comes down to practice. So I really encourage you guys to go through and just really focus on answering those past paper questions. And I hope that helped.